Thank you for inviting me for this session. My apologies, I could not be there in person, so I'm sending a recording. So today I'm going to talk about what we're working on called operating system as a service. And we all know that in the new world where AI and software is kind of merging, we need a new paradigm to think about what we call AI first operating systems, AI first companies and enterprises. And this talk is really about how to think about building such new platforms which are enabling AI first workflows across domains. So let's dig in. Um, so let me first start with what makes a great product. So if you think about, we are a product civilization. We are surrounded by amazing products, all the way from an iPhone to a Alexa to a Google Maps to a Chat GPT. And if I think about what makes a great product, five things come to mind. The first is these products have to scale. And we are talking about scaling of a digital product like YouTube and Instagram will scale with cloud. We're talking about how to scale a physical product, which can, like an iPhone manufacturing or a chip manufacturing, that will scale with our ability to do large scale manufacturing. And we are talking about digital physical products like Ola, Uber. They will scale with our ability to take care of the efficiency and the operations and make sure we have enough physical resources to scale them. The second I is the interface. All these products are very easy to use. A 5-year-old and a 70-year-old can use them. They are very intuitive, they are very elegant. And now they are going to become more and more natural, like speech first, gesture first, and inclusive products. So that's the second I. The third I is what I call intelligence. All these products are either AI first products or AI enabled products. They have some form of intelligence already baked into them, right? So if you look at Facebook, it will recommend you the right people. LinkedIn will recommend the right jobs. YouTube will recommend the right videos. ChatGPT is going to give the right answer. Ola, Uber will connect you to the nearest cabs. So they're all intelligent in their own ways. And these three I's make for what we call an MVP of a great product today. Then, if you think about the next I, which is what I call instantaneous, right? So we have been spoiled, if you will, by Google search for the last 20 years that we want instant results for everything, right? Even if ChatGPT is delayed in producing an answer, we become a little perturbed. Blinkits of the world are delivering in 7 minutes. Netflix can be watched instantaneously. So, now we are in the world of real time decision making, and that's a new I that we want to add. And if you think about loans and banking, back in the day, it would take months to get a loan. Now it is instant loans, right? So we are heading in the world of instant decision making. And finally, what is missing, and this talk is really about that part, which is what I call an integrated product, right? And we'll focus a lot on this idea of integration. And we'll talk about different products that are still out there but not yet fully integrated. So here's my, last three operating systems the world needs. So the first one is what I call domain operating system. So if you think about how each of the domains, commute domain, retail domain, telecom domain are done, they're still done in a very broken way. They have to be integrated into a operating system for each domain, and we're going to call them domain operating systems. The second is what I call the life operating system. So if you think about our phones today, they carry a lot of apps, some for food, some for entertainment, some for commute, some for education, some for health. So we are surrounded by a bunch of apps, and the next big thing that is coming is what we all can feel it. It's the super apps are coming, and the live super apps are going to power, in a single place, all the things we need for a life. And we need an operating system that deals with that kind of complexity and integrates our daily chores of life into a single super app. And then the third super app that is coming is what we call the work operating system. So if you look at how different roles and different professions are done today, right? So the lawyers, the teachers, the principals, the parents, the students, the doctors, we all use generic products like Gmail or meetings or WhatsApp groups or Excel spreadsheets to run our daily life through a collection of generic products. But there is a very strong need to create a work operating system. And what Salesforce has done, for example, has created a work operating system for a salesman. What Ola Uber have done, for example, is they have created a work operating system for a driver. So similarly, we need work operating systems in all domains. And I believe that in the future, the world will only, converge to these three operating systems or three types of operating systems, right? The super apps for life, the super apps for work, and the domain operating systems on which the whole thing is based on. So today we are going to talk about the domain operating system, how to think about it differently than what we have been thinking in the IT world for the last so many years. So let's talk about the idea of a product and how the products have evolved in the last 20 years, right? So when we think of products, there are physical products, right, which are physical in nature. You manufacture them, you supply them, you buy them, you deliver them. Then in the last 20 years, we have started looking at digital products. They have nothing physical. They are all purely digital in nature. And we have now accepted the world of digital and physical products. And now we are heading into the next world called the hybrid products or the digital physical products. And if you look at how retail is done, how Ola Uber is done, how healthcare is done, they're all going to have both a physical component and a digital component. And this is the future of how products are evolving. Now, companies who have built purely digital products have a very different mindset. The companies who have built a purely physical product have a very different mindset. And now we want to combine these two mindsets to create hybrid products. And that's what we'll talk about. Yeah. So from an AI perspective, if I think about the evolution of products, we started with physical products. They came with what we call programmed intelligence, right? If this, then that. And these products don't improve over time. They just do what they are told to do, and they don't deal with new situations or become better in their lifetime. The next version of the product becomes better. Then came what we call purely digital products, and they became better with the crowdsourced intelligence, right? As people were using Google search or Facebook or YouTube and giving feedback, these products became better. And that's what is the new skill we learned in the last 20 years, which is how to improve the products through feedback loops, right? And this is the crowdsourced intelligence. Now, in the next 20 years, we are going to build what I believe are called ecosystem products, right? So think of a smart city as a product, or think of a telecom network as a product, or think of the entire refinery as a product, or think of the entire ecosystem of agriculture of a country as a product, not just a drone or a fertilizer. Think of the whole healthcare or the e-commerce ecosystem. So these are what we call products of the future, and they are very complex. And our IT way of thinking and our AI way of thinking is not ready yet to conceive of how to build the backends for such complex ecosystems, right? So this talk will talk about these ideas. So we already live these products every day. So if you think of all the industry verticals, whether it is banking, hospitality, food, manufacturing, they are all complex ecosystems. If I think about business functions in any company, whether it is sales, marketing, finance, HR, they are also very complex systems. And if I think about social sectors and all the products we are using there, right, the public, digital public infrastructures, the defense, the railways, the legal system, the energy, these are also very complex systems. So this talk is really about how to systematically think about building an operating system for each of these, and what is that framework that will help us get there, right? So what makes these complex ecosystems? So first, they are very entity complex. They are not built with one entity or a few entities. They are built with hundreds of types of entities. So if you look at telecom, we have customer, tower, antenna, grid. Lots of entity types are coming together. Similarly, they are built with many, many interactions. It's not one interaction. So for example, in retail, if you look at retail at any given time, somebody is discovering a product, paying for a product, somebody is delivering a product, somebody is searching for a product. So lots of interactions are happening at the same time in a complex system. Again, there is data complexity. We are not dealing with just text data or just image data or just video data. If you look at the electronic health record of a person, it has time series data, your ECG, it has image data, your X-ray, MRI, it has your market basket data like the medicines you take, it has multivariate data, like the blood test report, and it has sequence data like a gene sequence. So we're not dealing with a few types of data, we're dealing with variety of data types coming together. And then we are not dealing with one or two metrics. We are dealing with lots of metrics that are at play. So if you look at Ola, Uber, for example, we have operational efficiency metrics, which affect customer experience metrics, which affect business and profitability metrics, right? So metrics are not independent. They are not few. There are many metrics which are interacting with each other. Then we have decision complexity. We are not dealing with one or two decisions. Like ChatGPT is a one decision system, or search is a two decision system, queries to ads and results. But in a world like retail, we are dealing with pricing decision, inventory decision, recommendation decision. All types of decisions are happening at the same time. And finally, we are not dealing with one microservice anymore. We are dealing with workflows. And this is one of the big transitions that we need to think about. How do we not think about microservices, but think about building workflows of all types? And these complex system needs all types of workflows that we'll talk about. Yeah. Now, why are we not there? So if I look at the world, I can think of companies which are, or domains which are pre-digital, right? The banking domain, insurance domain, manufacturing domain. And then there are post-digital domains like search engine, ChatGPT, Ola, Uber, food delivery. Now the post-digital domains have already built amazing platforms which are real-time, which are integrated and all of that. But the pre-digital domains, right, manufacturing, healthcare and all that, they are still dealing with a crisis. And what is the crisis? Let us understand the crisis. And the crisis is that if I'm dealing with a complex ecosystem, in the absence of an operating system, what we have to do, we have to patch together different systems procured from different vendors and put them together into what I call a digital slum. So now I have a lot of non-interoperable components, and then people are needed to download Excel from one, upload Excel to another, and we lost a lot of efficiency because of that. And this is true for a lot of banks, for a lot of retailers, for a lot of manufacturing companies that they have a broken backend. And we need to now move into a smart city mindset, right? How do we create a operating system for banking or healthcare or agriculture, which is seamless, which is integrated, which is interoperable, and all the great properties we expect from an operating system. Yeah? Now, the reason it is happening is because we understand that if you are a hammer person, everything looks like a nail to you. In any organization, I see three types of people. There are hammer people who are very good with tools, right? They are the data scientists, the data engineers, the AI scientists, and technologists and all of that. They are the people who know how to build, but they don't know what to build. And then on the other side, we have nails people who are very good at domains, right? They understand how insurance works, how retail works, how healthcare works, but they don't know how to build systems for those things. And what we need as we go forward are people who understand enough of the domains and enough of the digital. So we combine the two to create solutions for the different domains. And that is what the next generation technologists have to be. They have to understand domains well. They have to create systems and put them together and create operating systems for these domains. So before we go into the operating systems, let's see how to tame these complex systems into what I call systems and workflows. So what is a system? A system is a well-defined thing. So for example, in the airline industry, there is a system for booking a ticket. There is a system for entering the airports. There is a system for baggage handling. There is a system for aircraft maintenance. So these are the different systems inside an airline ecosystem. And then what is a workflow? Is a passenger. Every passenger is a workflow which uses each of the systems to get the job done end to end, right? So we understand that every complex system can be broken into systems and workflows. So let's look at the generic systems in any domain. So, there are system of sensors, which are anything that collects data is a sensor. So you can have sensors as sensor, all the transaction logs that are coming, all the feedback we are receiving from the world, from the surveys is all sensors, right? Then you have system of records. This is the long-term, short-term memory of the of the organization. And we store static knowledge, we store dynamic knowledge, we also store all the features we have created, all the inferences we have done, all the decisions we have taken. So we store everything in the system of records. Then we have a system of intelligence, which is about managing hundreds of models that are needed in a complex ecosystem. So we are not dealing with one ChatGPT model. We are dealing with hundreds of models of variety of types in a complex system. And how do we think about managing the life cycle of those models? Then we need a system of interaction. This is where either the customer is interacting with the system or a operations guy is interacting with the system of interaction with the ecosystem. So we need at least two systems of interactions, like you have a driver app for Uber and a customer app for Uber, or two system of interactions. Right? And then we have system of operations. This is when execution of operations is happening, and there can be digital operations like prices are changed automatically, or physical operations like delivery of products to customer. How do we think about the whole system of operations? And then finally, we need, and this is where the operating system mindset comes in, is a system of integration, which integrates all these systems into a single whole and all that. So let's take an example. For example, in retail or in any other domain, there are sensors as sensors, right? So there are sensors in many domains. They have to be integrated. There is instrumentation data coming from every domain, right? Like a car has an OBD port. The purpose of the car is not to be a sensor, but it collects a lot of instrumentation data. Then all the transactions that are happening are also sensors. All the images, videos, audio, social media, all the feedback we are receiving is all sensors. So how do we build a sensor ecosystem where we build all the sensors coming in real time? Then system of records has to store all the static knowledge of the domain, like what are the locations of all the cell towers in telecom, what is the product catalog in a retail is static knowledge. Then we have all the transactions, like every call creates a call data record. Every transaction that happens creates a record. Then all the sensor data coming directly from sensor has to be stored. All content, all features we have created have to be stored. All scores we have generated. So imagine a bank is creating a credit score of a customer every quarter. That also gets stored somewhere. All decisions we have made in the past have to be stored. Which campaign was sent to which customer. All that metrics have to be stored, and all the feedback has to be stored. So a system of records is a very comprehensive system that maintains the full record of an enterprise. So for example, in retail, I can think about the raw transactions that are happening. What are you searching? What are you ordering? What are you paying for? What customer care call you did? And then I also have uh, a system of feedback where I'm saying what ratings did you give, what reviews you gave. And using all that, I can create a system of features that I can create. So, for example, I can learn about the customer and say what categories you like, what brands you like, what attributes you like. And all this has to be stored somewhere in a feature store, right? So that's an example of system of records. And once I've done that, I can now use that system of records to say, hey, customer A likes certain brand, certain color style, customer B likes something else. If customer A is searching for men's shirt, he should get a different result than customer B. And this is how system of intelligence is built on top of system of records. Yeah. And finally, one more example. So the idea of system of intelligence is we are now designing models, we are training models, we are governing the models, we are benchmarking the models against existing models, we are deploying the models on the cloud or in the devices, and we are monitoring the models. And we are not doing it for one ChatGPT model, we are doing it for hundreds of models across the enterprise of all types of models, right? That's the scope of a system of intelligence. And finally, we have system of operations, which is all about delivering the end operations. So you can have customer operations, digital, physical, warehouse operations, physical. You can have store operations in retail. You can have supply chain operations, and these are all system of operations. So this is how we think about the five systems in a typical complex system. Now, what does the system of integration do? Is it does a lot more than this, right? So imagine you have a grocery business. So I can build a grocery profile of a customer. I can build a digital profile of a customer. I can build a fashion profile of a customer. I can integrate all that, again, the retail profile of a customer. Then I also can build a song profile, movie profile, and a TV profile of a customer. I can integrate all that to create a media profile of a customer, and then I can integrate those and I can create a customer 360. And that is how I get a full view of any customer. And now you can imagine that if a certain customer likes jazz music, he likes certain sports shoes, because now I am able to integrate multiple domains together, right? Another example, if you look at refineries, very complex system. Today, large refineries use hundreds of units to get from crude oil to final product. And now, without the system of integration mindset, we can only optimize each unit independently. But with the system of integration mindset, we can do a joint optimization of all the hundreds of units simultaneously. So that's a very big change in the way we can operate refineries. Another example in telecom, if I think about each AI model independently versus an architecture of AI, so think of one model in telecom that can tell you, given the tilt and capacity and location and height of each cell tower, I can tell which grid has high coverage, low coverage, high interference, low interference. I take that input and I can build another model that predicts the customer experience based on what the customer is doing and what the coverage is. And then I can build another model that can predict whether the customer will be a high value customer, retained customer, or engaged customer. And using that, I can build a business model that predicts whether I'll generate more revenue or what is my brand and market share going to be. So this new way of thinking, right, the system of integration integrates all the AI models into a single whole. And the new skill that we want is to think about domain, telecom domain in this case, think about all the AI models and how to integrate them seamlessly through a workflow where operational actions lead to operational metrics lead to customer experience, which lead to customer metrics, which lead to business metrics. So how do we think end to end and not just think about each microservices done well is the new skill that we need to develop system of integrations. Now let's move on to the workflows. So we talked about systems, now we'll talk about workflows. So every complex system works on different types of workflows. So one class of workflows are what we call execution workflows, where the things that need to happen will happen in a normal code. Somebody ordered a product, what are the 5 things need to do? Somebody said, let's install a cell tower, what are the 5 things we need to do? These are most of the workflows in any enterprise are execution workflows. Then exceptions happen all the time. Customer churned, cell tower is down. How do you predict these things before time, and how do you prepare for it? Is a AI first company that can do this better. Then how do you think about expansion, right? Whether to grow the inventory, whether to grow the infrastructure, whether to grow the market share. How do you think about expansion of a business? How do you think about the efficiency of a business? So there are efficiency workflows which can measure the efficiency like a store inventory or pricing efficiency or operational efficiency. And how do you continuously improve the efficiency of these systems? And how do you explain everything? How do you do root cause analysis in a complex system? Why the customer call drop rate has suddenly increased has to be done automatically. So this is going to become a very important use case for workflow design. And finally, how do you think about evolving all the models that we talked about, right? When a model is drifting for whatever reason, how do you retrain and automate the process that a system of intelligence needs? So let's take examples. So what is an exception workflow? A typical exception workflow is you monitor everything. You then pay attention to what needs attention, right? Discover what needs attention, understand the root cause, then synthesize an action, execute the action, measure the impact, and learn from feedback. So it's a typical exception workflow. We can apply this to all domains and all that. Some more examples of workflows, expansion workflows. If I think about customer acquisition is expansion, infrastructure growth, where to put the next cell tower, where to open the next cloud kitchen, market expansion, which market segment should I go after next, what new product features should WhatsApp add on its products, which content to acquire by Netflix and all that, which content or product to start selling in Amazon. These are all expansion workflows. And then we have efficiency workflows, which talk about how do you increase the efficiency of your inventory. Too much is bad, too little is bad. Pricing, too much is bad, too little is bad, and so on and so forth. So there are lots of workflows that are running complex ecosystem. So hopefully we understood that our mindset has to change. We cannot just think about microservices separately, AI separately, but think about integrated way of putting these workflows together. So now let's take some concrete examples of workflows and notice that we are trying to integrate workflows. They are AI embedded. AI is not an afterthought. They are going to do real-time work and they are deterministic in nature, right? All the properties that agentic does not have, we need, right? Uh, so if I think about workflows, I can look at assisted intelligence, augmented, autonomous, and then I have added three more: proactive, ecosystem, and emergent intelligence. So let's take an example. One of the most critical use case in agriculture is the daily personalized, contextualized advisory for every farmer, right? And we get a lot of calls in our call centers every day in Reliance Foundation, many other foundations. And we cannot handle all the calls because there is a human who is trying to give the advisory. Now, to solve this problem, we need to scale up and build a AI-based advisory system which works in all languages and all that. So imagine a farmer is calling. How do we think about this as a workflow and not as a single API, right? We're not building a single API, we are building a workflow now. So we are going to need speech to text, text to intent models that will help us understand in all languages what a farmer is needing. We are going to need an AI-based expert powered by domain knowledge of agriculture, right? Which crop, which soil, how much fertilizer at which stage. How do we think of domain knowledge and static knowledge of agriculture, coded not as a bunch of documents inside a chat GPT, but a knowledge graph of entities and relationships. How do we think about the farmer profile? How do we think about all the sensors? And now the AI expert can give information, it can give content, how to apply the fertilizer, and it can even deliver the fertilizer through a drone to the farmer, right? Now, this is the new mindset that we want to create, which is in order to deliver personalized, contextualized services, we need to create a workflow mindset, right? We don't think in terms of AI, we don't think in terms of individual microservices, we think in terms of workflows. Think of them as the molecules. We think in terms of molecules, not atoms, right? Um, and also notice that these workflows are made up of multiple systems. So what is the system of interaction here? Is the phone call, the audio-based interaction between the farmer and the AI system. The system of records, we need two types of records. One is the static knowledge of the domain. In every domain, there is a static knowledge and there is a dynamic knowledge. So the static knowledge is the knowledge of, let's say, all the agriculture knowledge, and the dynamic knowledge is all the knowledge about the farmer profile every day, what is the state of the crop and all that. What are the system of intelligence? Again, we have AI systems here and there in the workflows. Then we have system of sensors, which is all the sensors that we need to make the real-time decisions. And finally, we have system of operations. So the point of this discussion is that now we understand that we need different systems and each workflow is made up of components from different systems. And this thought process is going to help us build what I call the operating systems for the future. Now let's take an example of the critical problem in healthcare. So today in third world countries, the global south, there's a lot of dearth of good doctors available to every patient. So what do we need? And the role of a doctor is really to do preclinical diagnosis. So again, imagine an AI doctor who is able to take the initial symptoms, create a preclinical diagnosis of the top 5 diseases, gets it approved by a real doctor, and then, AI decides what is the investigation needed, again get it approved by a real doctor, and then the reports come, AI analyzes the report, creates a post-clinical final diagnosis, again get it approved by a real doctor, and then does a prescription, because prescription is also an art, and again get it approved by a real doctor. So this is a workflow again, but here the key quality is the AI box, the orange boxes are always followed by a green box, which is a human box, right? And this is what we call augmented intelligence. And the role of humans in the future is going to be curation, not creation. So we are not going to analyze reports ourselves. We are not going to do diagnosis ourselves. But we are going to look at the output of an AI system, and this is going to be true for healthcare domain, for journalism, for software engineering. In every domain, the role of humans is evolving to become curators of what AI is creating, and that's a new world, and we need to redesign our workflows in such a way that human and AI are working in tandem with each other to create these experiences. Another kind of workflow is what we call autonomous intelligence. So oftentimes, crimes are happening, cameras are there, but there is nobody watching all the cameras in real time. So how do we now create automated workflows that say events are coming, actions are getting detected. If there is a harmful action, alarms are raised, face detection is happening, authorities are notified, family is notified. How can we not create such workflows and have only two types of things in the system? So we have functions, which are APIs, if you will, and we have events, which are the nouns of the system, and functions are the verbs of the system. And this is the new programming paradigm. If somebody can put this diagram together, the code should get generated, and interfaces should get created, and events should start flowing through Kafka queues, and real-time decisions should happen. This is possible only if we create a operating system mindset working backwards from user domain. So this is directly from sensor to action. We can actually create this. Another critical problem we will solve in education is what we call mastery learning, right? So if you think about education, it's a one-size-fits-all education system, and it's only 20% efficient. How can AI help? Again, think of a student and a concept. So initially, the student is not ready to learn the concept, and suddenly he is ready to learn the concept because he has mastered all the prerequisites of that concept. So AI takes the student to the next level. Then, the right videos to watch, the right homework to do. Every student gets a different version of it, right assessment to do. And then you have mastered the concept. You also get to teach the concept to three other kids. And now you have really crossed that concept and you move on to the next one. So this is what I call a journey mindset. So if you think about the journey of a student through a learning process, journey of a customer in a bank or a retail business or an insurance business, it's all journey. So how do we think about journey from an entity point of view and create workflows around that? Yeah. Another one, if you think about what a farmer does every day, he goes around the crop and takes, understands what's going on. So imagine a farmer takes a picture of a crop. There is one AI that says what crop, what stage. Another AI that says what is the stress of the problem. And this workflow is the diagnosis workflow. And it triggers other workflows, right? So maybe there is a water problem. So it triggered a water problem workflow and says, oh, there is an irrigation advisory I need. And then imagine that system is connected to the tube well, the system of operations, and it even turns on the tube well and finishes the job. If it's a nutrition problem, there is a drone that delivers the right fertilizer to the right part of the crop. And if it's a pest problem, we deliver the right pesticide. And now, why should even a farmer take a picture if satellite can do the job or if drones can take the picture every morning? So this is what we call uh, integration mindset, where we integrate all the workflows that we can think of into a single architecture of functions and events, right? And what have we done? We have reimagined a whole domain and a whole set of workflows that can be done very differently in the post-AI world. Uh, Finally, if I think of a whole domain and say what are the workflows inside a retail domain, top workflows. So one workflow is the order collection, another workflow is demand forecasting, another workflow is delivering the product from where the demand is low and the inventory is high. I want to do the optimization, and then I can do profiling as a workflow, and finally I can do inventory management as a workflow, right? So this diagram is the new skill, both for domain guys, for data scientists, and for technologists to think about a domain as a whole, to think about the entire workflow, to think about all the opportunities of AI, operations, sensors, and everything in the same diagram, right? And once we have a blueprint like this for any domain, we are now ready to build operating systems for that domain, right? Uh, uh, so now, So now let's talk about a new way of thinking about what I call emergent intelligence, right? So if I see this picture, it is really a collection of pixels, but if I see it from away, it looks like a picture of an Einstein, right? Or similarly, if I look at what fishes are doing individually, but when I look at them as a collective, it's an emergent behavior, right? If I see a bunch of drones, they are doing their thing, but they are creating a what I call an emergent effect of a girl dancing in the sky, right? So this idea of emergence is that the whole is always greater than the sum of the parts. And we have seen emergent behavior in nature. So for example, if you think of functions like breathing and photosynthesis, these two functions have been there, but they created an emergent behavior called oxygen cycle. Similarly, if you think about all these functions of evaporation, transportation, condensation, precipitation, they have created an emergent behavior called a water cycle. So how do we now think about emergence as a new philosophy of building architectures? So let me talk a little bit about that. And where do we see emergence? Emergence is everywhere. If you think about generalization of an AI model, which is more than just the sum of the data. If you think about reasoning, is just more than the paths that we create is more than the states and action. If you think about the documents we generate through ChatGPT, is more than just a collection of tokens. And if you think about an ecosystem, it's more than just a collection of workflows, right? So let me give an example of a programmed workflow versus an emergent workflow. So let's say I have a workflow in mind that I want to catch bad guys in a blacklist through a camera. So I have a camera feed coming, I get the frame, I get the images, I detect faces, I compare faces to blacklist, whitelist, and I get my job done. And this is what we typically do. We typically think about architecting a system because we have a workflow in mind and we can put together all the APIs to create a workflow. Now let me switch this in a different way and let me think about what I call emergent intelligence, right? A new way of thinking about architecture. So let's say I don't think about a workflow, I just think about the events. So there is an event called image, and now I think about all the things I can do with images. So I can detect faces, detect scene, detect objects. I can do everything with an image. I put those functions in front of those queues, and I can put all the sources of images into that. Then I think of another type of event, let's say video. Again, I think of all the things I can do with the videos. So detect action, extract frames, and put them in the right place, and then continue. And then I think about all the things I can do with faces, with scenes, with objects. And now imagine the previous workflow we had in mind called a surveillance video system catching bad guys from a blacklist. Now imagine that that workflow is there in place, but it is not working because the bad guys are not showing up on surveillance camera. And now suddenly somebody added YouTube videos onto the video queue. And if a bad guy is showing up on a YouTube video, suddenly he'll get detected. Now, this behavior, which we did not think about earlier, therefore we did not build a workflow for that, is now happening in an emergent workflow. So what is an emergent workflow? Emergent workflow is really about not having workflows in mind, but thinking about events first and then creating everything that needs to be done on an event. Automatically, all the workflows that you can imagine and not imagine will be part of an emergent architecture. So for me, this is the next step after current AI. Before we go to AGI, emergent intelligence is the next building block towards that. So now let's talk about operating systems as services. So if I think about how the enterprises are running today, we have the front end and the back end. But what we want to build is the back end of the back end, right? So if I think about all the events coming from all the systems into a standardized format through the stimulus layer, so I get all the events, I run all the AI models, I finish all the workflows, I deliver all the decisions, and I convert it back to the response that you need, then I have a complete architecture of a domain The good news is I don't have to build this again and again for the same domain, right? So if I think about this, there is a system of interaction at the top. There is a system of sensors where the events are coming. There is a system of intelligence running all the workflows, and there is a system of operations delivering all the decisions, and a system of records storing all the intermediate stuff, right? So how do I now think about operating system as the new thing? So what is a agriculture operating system, for example? Right? What are the input events? What are the static data, dynamic data? What are all the AI models? What are the decisions that I will deliver? Similarly, what does a healthcare operating system mean? Input events, output advisories, all the AI models, all the content, all the digital twins of a patient. How do we think about education operating system? Again, all the input events, output events. How do I think about manufacturing operating system? So, and so on and so forth, right? So we can think about operating systems in every domain now. So while Satya Nadella is saying SaaS is dead, we are saying operating system as a service is the new thing. And all our architecture thinkers, AI thinkers, and domain thinkers have to come together to put these operating systems in place, right? Same thing with military operating system. So really, how do I think about all this? So we build a core operating system layer which doesn't know anything about the domain. It only knows functions and events. On top of it, we build retail operating system, telecom, banking, domain operating systems. And then each of the customers or clients in that domain will connect to those domain operating system on the input and output side. And no, Amazon, Best Buy, Walmart don't have to build their own versions of a retail operating system. The unique thing about each one is their data, their customer, their models, but the workflows are common, right? In retail, workflows are common in telecom and banking, right? So that's how we can break this down into a three-layer architecture. So how do organizations move? They go from manual to digital to automated to intelligent to integrated organizations. How do we think about a workflow? What metrics we are solving? What decisions, models, features, and therefore data? How do we think about our AI journeys? Organizations have to move away from business intelligence to emergent intelligence. And finally, how do we execute all this? Is we execute integration backwards. So we think about amoeba as the first integrated life form, and then evolution will happen over the next so many years, right? Similarly, if I think about an integrated operating system in a domain first, and then start implementing the components, and then start improving them over time with data, that is how we think about it. Yeah? So these are this is what I wanted to share with you today. Thank you for your time. If you are interested in working on these ideas or if you have thoughts and inputs, please connect with me on LinkedIn. Thank you.